Welcome to the Microsoft Virtual Training Day for the Data Fundamentals course. So in this training, we're going to take you through the fundamentals of data and database concepts. We're going to take a look at core data concepts, and we'll teach you what relational data is, what that means, what non-relational data is, and what that means, as well as take a look at data analytics solutions in Azure, so that at the end of this training, hopefully, you'll have the skills to both provision and deploy data services in Azure. Now, in Module 1, we're going to take a look at core data concepts. We'll also take a look at some of the roles and responsibilities in data. We'll have a look at some of the relational data concepts as well as non-relational data concepts, and we'll take a look at some of the data analytics concepts in Azure as well. So let's get started with Module 1. So who am I? My name's Michelle, and I am an Azure Technical Trainer at Microsoft, which means my job is to help upskill people to the cloud. Now, previous to this, I was an Azure specialist and an Azure TSP. So I've been doing Azure for quite a while. Outside of Microsoft training, teaching, and working, I like to travel, and I'm a big foodie as well. So I follow where my nose takes me. I also do a bit of coding and writing in my spare time. So if you're interested, you can find some of my blogs on my social media. Now, on the top right corner there, you'll see a big Azure Data Fundamentals badge. Now, if you sit the DP 900 exam and you pass it, this is the certification that you'll get. So you'll get the Azure Data Fundamentals certification as well as a badge that you can use to show off. Now let's take a look at the course agenda for this training. We've got 4 modules in this course, starting with Module 1, where we're going to explore core data concepts. And so we're going to have a look at some of the roles and responsibilities in data. We're also going to talk through some of the relational data concepts and non-relational data concepts, as well as concepts to do with data analytics. In Module 2, we're going to explore relational data in Azure a little bit more in depth. So we're going to have a look at some of the relational data offerings in Azure, how to provision and deploy relational data offerings in Azure, and how to query relational data in Azure. In Module 3, we're going to explore non-relational data in Azure. And so again, we're going to have a look at how to provision and deploy non-relational data services in Azure. And we're also going to have a look at how to manage non-relational data services in Azure. And finally, we're going to wrap up with Module 4, where we're going to explore modern data warehouse and data analytics in Azure. And so we're going to have a look at what a modern data warehouse looks like, data ingestion in Azure, some of the data storage and processing capabilities in Azure, and finally, we'll have a look at what Microsoft Power BI does. Lesson 1. Explore core data concepts. Now, what is data? Well, by definition, data is a collection of facts such as numbers, descriptions, and observations used in decision making. So you can classify data as structured, semi-structured, or unstructured. Now, structured data is data that adheres to a schema. So all of the data has the same fields or properties. Structured data can be stored in a database table with rows and columns. Semi-structured data is data that doesn't fit as neatly into tables, rows, and columns. Instead, semi-structured data uses tags and keys that organizes it in some sort of hierarchy. And so a typical example of semi-structured data is data stored in JSON format or JavaScript object notation. Now, unstructured data does not follow any schema or structure, nor does it need to be organized in any particular way. So unstructured data can be anything such as video files, image files, text files, or audio files. When we talk about data, we typically talk about transactional versus analytical data stores. So a transactional data store or a transactional system is often what most people consider to be the primary function of business computing. A transactional system records transactions, and these transactions could be financial transactions such as movement of money between bank accounts in the banking system, or it could be a transaction that is part of a retail system, like tracking the payments of a good and services that a customer has paid for. So you can think of a transaction as a small, discrete unit of work. Now, an analytical system is designed to support business users who need to query data and get that big picture overview of their organization. So analytical systems is really concerned with capturing raw data and using it to generate insights. So an organization can then use these insights to make business decisions. So for example, you might be a manufacturing company who wants to find out the trends in the industry and determine which products to continue to launch or launch next to maximize profitability. And so you can use an analytical system to help support that decision-making process. Now, transactional systems are often quite high volumes. Sometimes they can handle millions of transactions in a single day. And so the data being processed needs to be accessible very quickly. So the work performed by a transactional system is often referred to as an online transactional processing system, or an OLTP system. To support this fast processing, the data in a transactional system is often divided into pieces. So for example, if you're using a relational data system, each table involved in the transaction contains the columns necessary to perform that transactional task. So if we're talking about a bank transfer example, then we might have a table that holds information about the funds in an account that might contain the customer account number and the current balance. Other tables not involved in the transfer operation would hold information like name, address of the customer, and maybe account history. Now, splitting the tables out into separate groups or columns like this is called normalization. So normalization can enable a transaction system to cache the information required to perform the transactions in memory and really speed up that throughput to process the data. While normalization enables fast throughput for transactions, it can actually make querying quite complex. So queries involving normalized tables will frequently need to join the data together across several tables to be able to execute that query. And so this can actually make it quite difficult for business users who might need to examine the data. Now, most analytical data processing systems need to perform quite similar tasks, such as data ingestion, data storage, data transformation, data querying, and data visualization. So this is a pipeline of services to build an analytical system. Now, data ingestion is really about capturing raw data. So this data could be taken from devices that are, for example, measuring environmental information like temperature, pressure, or it could be from point of sales devices that's recording items being purchased by a customer in a supermarket, or it could be recording financial data where we are collecting the movement of money between bank accounts, or it could be weather data that's coming from a weather station. And so some of this data can also come from your OLTP systems or your relational databases from on-premises. So to process and analyze this data, we must first store the data into some repository of some sort. And this repository could be a file store, it could be a document database, or it could be a relational database. And then we have to transform and process this data because the raw data might not be in the format that is suitable for querying. What that means is your data could contain anomalies. So these anomalies should be filtered out. And it might require some transformation of some way, shape, or form. So for example, dates or addresses might need to be converted into a standard format. Also, after the data is ingested into a data repository, you may want to do some cleaning operations to remove any questionable or invalid data, or perform some aggregations such as calculating profits, calculating the margin, or any other key performance metrics or KPIs that are used to evaluate how your organization or your business is doing in terms of growth and performance against the industry or in the market. Now, once we've processed and we've transformed the data and we make it ready to be used, we can then start querying and doing some analytics on our data. So this typically happens after we've ingested and transformed our data. During the data querying process, we might be looking for trends. We might be attempting to find certain root causes or problems or issues that is happening in our organization or business. So there are many database management systems that provide the tools to enable you to perform these ad hoc queries against your data and generate regular reports. Now, the data, once we have the results from our queries, we probably want to visualize it and present it in a visual way. And so this is where the data visualization stage happens, because data is usually represented in tables with rows and columns, and it's not as easy to digest in that numeric format or in those tables and documents. And so visualizing the data can often be quite a useful tool to examine the data. And so you can generate charts like bar charts, line charts, plotting the data onto a geographical map if it's geographical data. And you can really illustrate how data changes over time and pick out the trends in your data. So Microsoft actually offers a visualization tool to enable you to do so. The service is called Microsoft Power BI, and it provides a rich graphical representation of your data. Now, data processing is simply the conversion of raw data to some meaningful information through a process. So depending on how the data is ingested into your system, you could process each data item as it arrives, or you could buffer the raw data items and process it in groups. So processing data as it arrives is called streaming, and buffering and processing the data in groups is called batch processing. So in batch processing, the newly arrived data elements are collected into a group. Now, the whole group is then processed at some future time as a batch. Exactly when each of these groups is processed can be determined in a number of ways. So for example, you can process the data based on a scheduled time interval, say for example, every hour, or you could use some trigger. Say, for example, when a certain number of data items have arrived, then we trigger that process to go and batch process it. Some of the advantages of batch processing is that you can process large volumes of data at a convenient time. And so you can schedule that run at a time when, for example, your computers or systems might otherwise be idle. So you can batch process overnight, or you can batch process during off-peak hours. Some of the disadvantages of batch processing is that there is often a time delay between ingesting the data and getting the results. So all of the batch data jobs, input data, must actually be ready before a batch can be processed. This means the data needs to be carefully checked, because if we identify any problems in the data, it can cause the batch job program to crash. And so the input data must be thoroughly checked before the job can be executed. Even very minor data errors like a typo in the dates can actually cause the batch job to not run. Now, in stream processing, each new piece of data is processed as it arrives. So for example, as we ingest that data, we process it in real time. And so streaming handles data in real time. Unlike batch processing, there's no waiting until the next batch interval to then process that data, because we're actually processing each individual pieces of data item as they come in. And so stream data processing is very, very useful for scenarios where we're dealing with new dynamic data that is being generated on a continuous basis. Lesson 2, exploring roles and responsibilities in the world of data. So there are 3 key roles that deal with data in most organizations, and these are data administrator, data engineer, and data analyst. As a data administrator, their main role is really to manage databases, assign permissions to users, store backup copies of data, and restore data in the case of any failures. As a data engineer, their role in data is to work with the data, to apply data cleaning routines and transformations, build out those data pipelines and processes, identify business rules, and really turn data into useful information and prepare it for data analytics workloads. And as a data analyst, their role is really to explore and analyze the data by creating visualizations and charts which help enable an organization to make better and more informed decisions. So some of the common tools that a database administrator might use includes Azure Data Studio, SQL Server Management Studio, as well as the Azure Portal or the Azure CLI. So a database administrator will need to use these tools to configure the overall availability of their data servers and databases. They're responsible for maintaining consistent performance and optimizing the data servers and databases. So they need to work with the stakeholders to ensure that policies are implemented, that the tools and processes are set up in place, and that backup plans are available to recover any data servers or databases that might fail due to some error because of some natural disaster or human-made error. And so they're also responsible for the security component of the data servers and databases, which means they're the ones who grant access rights to users to determine who gets the right to access databases and who doesn't. Some of the tools that a data engineer might use includes Azure Synapse Studio, SQL Server Management Studio, as well as the Azure Portal and Azure CLI. So as a data engineer, their responsibility includes maintaining and managing data privacy within the cloud, as well as on premises. So they're also responsible for managing and monitoring data stores, the data pipelines, making sure that the data performs as expected by doing a combination of cleaning and transformation on the data to prepare the data for data analytics queries. Some of the common tools that a data analyst might use includes Power BI Desktop, Power BI Servers, and the Power BI Report Builder. So data analysts are typically those who design and maintain scalable business models with data. They might also engage with cleaning and transformational activities to further advance their analytics or build reports and visuals to help business decision makers digest that information and the results in a more visually pleasing way. The main goal of a data analyst is really to turn the raw data into insights based on the business's requirements, and then that insight can then be turned into actionable decisions. Lesson 3. Describe concepts of relational data. We'll start with tables. So a table is where data is stored in relational databases. They consist of rows and columns, and all the rows have the same number of columns. Each of the columns is defined by a data type. Now, one of the main benefits of a computer database is that they make it easy to store information so that it's quick and easy to find. For example, an e-commerce system might use a database to record information about the products that this particular e-commerce site or organization might sell, as well as some of the details of their customers and the orders that they've placed. And so we have a customers table here, which stores the customer ID, the customer name, and the customer phone number. Now, a relational database provides a model for storing this data and query capabilities that enables us to retrieve this data very, very quickly. So let's say I wanted to look up customer ID 106 from this table. I can see that it's Alex Peterson. In a relational database, you typically model collections of entities from the real world as tables. So for example, a customer is an entity, therefore we create a customer table. An entity generally describes a thing about information which we want to hold inside a database. In the e-commerce example here, we might also create tables for products and orders because they are also entities in the real world. Now, table contains rows, and each of these rows represents a single instance of an entity. So what that means is each row in this customer table contains data for a single customer, and each row in the products table will define a single product in the products table, and each row in the orders table will represent an order made by that customer. Now, the rows in a table can have more than one columns that define the properties of the entity. So the properties in this case would be customer ID, customer name, and customer phone number. And all the rows in the same table will have the same number of columns. And some of these columns are actually used to maintain relationships between tables, which is where relational databases or relational model gets its name from. Typically, when we're designing a relational data model, we need to normalize the data so that we can reduce storage, we can avoid data duplication, and improve data quality. So, for example, instead of storing a replica of the customer's details in the order table, we would split out that data into two separate tables and reference the customer table from the orders table. So the orders table now contains both a customer ID and it also contains a product ID. Now the customer ID relates to the customer ID in the customer table. And similarly, the product ID will relate to the product ID in the products table. And so we typically design a relational database by creating these relational data model, and each table will have these primary keys, so the customer ID in the customer table, order ID in the order table, product ID in the product table. These are all examples of primary key. And the primary key is then used to associate with a foreign key in another table. And so the customer ID and the product ID in the orders table are foreign keys. And this foreign key references the primary key and is used to establish that relationship between tables. Now, another concept to know in relational data is indexes. So an index helps you search for data in the table. You can think of an index over a table like an index at the end of a book. So the index at the end of a book helps you find certain pages relating to certain topics or subjects, so that when you want to find a reference to a particular topic or a subject, you simply have to look it up in the index at the end of the book and then go to that specified page number. Imagine that you didn't have this index. So to find out about a particular topic or subject, you'd have to read through the entire book to be able to find that information out. And so similarly, when we create an index in the database, we specify a column from the table where this index contains a copy of this data in a sorted order with pointers to the corresponding rows in the table. And so when the user runs a query that specifies this column in, say, for example, the where statement clause, the database management system can then use this index to fetch the data much more quickly, instead of having to scan through all the tables in the entire database row by row to find out that information. So you can create many indexes on a table. Say, for example, if we wanted to find all the customers for a specific region, then we can create another index on the customer ID column from the customers table. But indexes are not quite free. So an index would consume additional storage space, and each time you do an insert, update, or delete to a table, the indexes for that table needs to be maintained. And so this additional work can actually slow down your database operations. And therefore, if you're deciding to use indexes, you must strike that balance between having indexes to speed up your queries versus the cost of performing your database operations. Now, typically in a table that is read-only or contains data that is modified infrequently, more indexes will actually help improve the query performance. If a table is queried infrequently, but it's subject to a large number of inserts, updates, and deletes, then creating indexes on that table can actually slow your database systems down. Now, a view is a virtual table based on the result set of a query. So in the simplest case, you can think of a view as a window on specified rows in an underlying table. So you can query the view and you can filter the data in much of the same way as you would with a table. Now, a view can also join tables together. So if you regularly need to, say, for example, find the details of customers and the products that they've ordered, you could create a view to do so. Lesson 4, exploring concepts of non-relational data. Now, in a non-relational system, you typically store the information for entities in collections or containers rather than relational tables. So two entities in the same collection can have a different set of fields rather than the regular set of columns found in a relational table. This lack of fixed schema means that each entity can be self-describing. So often this is achieved by labeling each field with the name of the data that it represents. So for example, a non-relational collection for customer entities might look something like this. Now, a key aspect of non-relational database is that they enable you to store data in a very flexible manner, because non-relational databases don't impose a schema on the data. Instead, they focus on the data itself rather than how to structure it. So this approach means that you can store information in the more natural format that might mirror the same way that your applications might query and consume and use it. So if we take a look at this example here, the fields are prefixed with a name, and some fields might actually have multiple subfields. So for example, if we have a look at telephone, we can have a home telephone, a business telephone, a cell telephone. And these multiple subfields are denoted by enclosing them between square brackets. And so if we wanted to add a new customer to this non-relational data store, it's a matter of inserting an entity with its fields labeled in some meaningful way. Now, the application that queries this data must be prepared to actually pass the information in the entity that it retrieves. The data retrieval capabilities that a non-relational database can actually vary. So each entity should have a unique key value. For example, the ID needs to be unique. So the entities in the collection are usually stored in some key value order. For example, the key here is ID, name, telephone, and address. And the value would be 1, Mark Hansen, the phone numbers and addresses of Mark Hansen. The simplest type of non-relational database enables an application to either specify the unique key or a range of keys as the query criteria. And so in this example, the database would enable an application to query customers by ID only. Now, filtering data on other fields would actually require us to scan through the entire collection of entities, parse each entity in turn, and then apply the query criteria to each entity to find the matches. And so, for example, if we were to do a query that fetches the details of the customer by ID, we can quickly do so. But if we had a query that attempted to find all the customers with the UK address, for example, we would have to iterate through every entity, and for each entity, examine each field in turn. And so you can imagine a database that contains millions of entity records. This kind of query would actually take a considerable amount of time to run. And so you would typically query a non-relational database with its unique key value for each entity. Some of the more advanced non-relational systems supports indexing, much like the indexing in the relational database. So queries can then use the index to identify and fetch the data based on a non-key field. Some of these more advanced non-relational systems that supports this are, for example, Azure Cosmos DB, which is a non-relational database management system that's available in Azure. And so with this indexing, we can actually query non-key fields from a non-relational database. Now, semi-structured data is data that contains fields, and the fields don't have to be the same in every entity. So you only define the fields that you need on a per entity basis. The data must be formatted in such a way that an application can then parse and process it. And one of the more common ways of doing so to store the data for each entity and fetch it is using JSON. So JSON stands for JavaScript Object Notation. It's a format that's typically used by JavaScript applications to store data in memory, but it can also be used to read and write documents to and from files. So typically, a JSON document is enclosed in curly braces. Each field has a name followed by a colon and then the value of the field. The fields can contain simple values or could contain sub-documents, each also starting with its own curly braces. Fields that contain multiple values are held in arrays, and the arrays are the values that's denoted in square brackets. Inside these values, you can actually define whatever you like. So the important point to make here is that as long as you follow the JSON grammar, you can import any type of data into the value. Now, when an application reads a document, it needs to use a JSON parser, because this JSON parser will then break up the document into its component fields and extract out the individual pieces of data. Now, a row is a row-based format. So it was actually created by Apache. Each record contains a header that describes the structure of the data in the record. The header is actually stored as JSON, and the data is stored as binary information. So an application will typically use a header to parse the binary data and extract out the fields that it contains. Azure is actually quite a good format for compressing data and minimizing storage and network bandwidth requirements. Now, Oracle RC stands for Optimized Row Columnar Format, and it organizes data into columns rather than rows. So it was developed by Hortonworks for optimizing read and write operations in Apache Hive. Apache Hive is a data warehouse system that supports fast data summarization and querying over a very large data set. So Hive also supports SQL-like queries over unstructured data. Now, an OGG file contains strips of data. Each strip holds the data for a column or set of columns. A strip contains an index into the rows in the strip, and so the data for each row, and there's also a footer that contains statistical information. So this statistical information are things like the sum, the count, the max and min of that particular strip of data, which you can access. And Parquet is actually another columnar data format. It was created by Cloudera and Twitter. Parquet file, they contain row groups. So data for each column is stored together in the same row group, and each row group contains one or more chunks of data. So a Parquet file includes metadata that describes the set of rows found in each chunk. Now, an application that can then use this metadata to quickly locate the correct chunk for a given set of rows and retrieve the data in the specified columns for these rows. So Paki is it's developed for storing and processing nested data types quite efficiently, and it supports very efficient compression and encoding schemes as well. Now, unstructured data is data that doesn't naturally contain fields. So examples include video files, audio files, and other types of media streams. Each data item is a blob or binary data, and so you can't actually search on any specific elements inside this kind of data. You might, for example, use Azure Blob Storage to store this unstructured data. So blob actually stands for binary large object. And in Azure Blob Storage, block blobs are supported. So block blobs is used for basic read and write operations, and it has no internal search capabilities. So you could also consider, for example, files as a form of unstructured data. Although some files actually have metadata that kind of describes what the contents of this file might contain. So you can think of an image or photograph as a file, Word document as a file, Excel spreadsheet, they're all files. And some of that metadata for the files might include who the owner of the file is, when that file was created. So all the properties of the file, that's all the metadata. But the main content of the file itself is actually unstructured. Now, you might have heard or seen the term NoSQL floating around when you're reading about non-relational databases. NoSQL is rather a loose or generic term that refers to or simply means non-relational. So some people debate that NoSQL means not SQL or not only SQL, but essentially it just means non-relational data. Now, NoSQL or non-relational databases generally fall into 4 categories. So we have key value stores, document databases, column family databases, and graph databases. Now, a key value store is the simplest and often quickest type of NoSQL database for inserting and querying data. So each data item in the key value store has 2 elements. It's got a key and a value. And the key uniquely identifies the item, and the value holds the data for that item. So this value is opaque to the database management system, which means the database management system only sees the value as an unstructured block of data. Vice versa, if the value was not opaque, so transparent, that means the database management system actually understands all the fields and how that particular data is organized. So a relational table, for example, has a transparent structure. Now, to query a key value store, we must specify the keys which identifies the items to be retrieved. So you can't search on the values. So an application that retrieves data from a key value store is responsible for passing the contents of the values returned. And write operations for a key value store is typically restricted to inserts and deletes only. So if you need to update an item, you must first retrieve the item, modify it in memory, and then write it back to the database. So it's typically a retrieve, modify, and insert right back to the key value store. The focus of a key value store is really the ability to read and write data very, very quickly. And so that's why search capabilities are secondary. So key value stores are great for data ingestions where we're dealing with a large volume of data that's coming in continuously as a stream and needs to be stored very, very, very quickly. Azure Table Storage is an example of key value store, and the Azure Cosmos DB actually implements a key value store using the table API. Now, in a document database, the data is stored as documents, and each document has a unique ID. but the fields in the documents are transparent to the database management system. So document databases typically store data in JSON formats, but they can also use other types of encoding. So it could be XML formats, YAML formats, or binary JSON. Documents could even be stored in plain text. So the fields in the documents, they are exposed to the storage management system, which enables an application to query and filter the data by using the values in the fields. Now, typically, a document contains all the data for an entity. So what items that might constitute to an entity are application specific. For example, an entity could contain the details of a customer, its order, or a combination of both. So a single document might contain information that would typically be spread across several relational tables in a relational database management system. A document still does not require all the documents to have the same structure. So this kind of free-form approach means we have a lot of flexibility in terms of the data that we insert into the document store. And applications can store different data in documents as business requirements change. And so an application can then retrieve the documents by using the document key, and this key is the unique identifier for the document. So some document databases can create this document key automatically. Others might require you to specify which attribute of the document to use for the key. The application can also query documents based on values of one or more fields, because some document databases might support indexing to facilitate this fast lookup of documents based on the fields instead of the key. So most document databases, they are used to ingest large volumes of data very rapidly in comparison to a relational database, but they're not as optimal as a key value store for this kind of processing. The main goal of document database is that it has that search query capabilities that a key value store typically doesn't have. Now, Azure Cosmos DB actually implements a document database using its core SQL API. A column family database organizes data into rows and columns. So examples of the structures includes awk and parquet files. So a column family database can appear very similar to a relational database, at least conceptually. But the real power of a column family database lies in its denormalized approach to structuring sparse data. So you can think of a column family database as holding tabular data comprising of rows and columns, but you can divide the columns into groups known as column families. So each column family holds a set of columns that are logically related together. Say, for example, we can use a column family database to group data into two column families that might hold both customer information and housing information. And then we can fetch for both customer information and housing information at the same time with a single query. Now, an analogy that I like to use to explain column family databases a little bit more is, let's imagine I held a virtual video treasure hunt through YouTube. I uploaded 10 videos to YouTube. Each video are 10 minutes in length. And I tell you that I have hidden a secret letter inside each of these videos. Now, if you were able to find each letter and you can combine it to form a word, then the secret word is actually the location to the prize for the treasure hunt. Now, after watching a couple of these videos, you notice that I've hidden the secret letter at exactly the 4-minute mark for every single video, which means if you go to the 4-minute mark for every single one of these videos, you'll be able to find the secret letter and in turn, the secret word. Now, in this analogy for a column family database, the video is essentially the column, the group of 10 videos is the column family, and each second of the video represents a row in each of the columns. And the 4-minute mark is actually the key used to fetch the data for the rows in each of the columns. So you should always implement your column families to be most optimal for some of your most common queries that your applications might need to perform. Each row in a column family database contains a key, and you can fetch the data for a row by using this key. So in most column family databases, the column families are stored separately, and the data for a single entity that spans multiple column families will have the same row key in each column family. One of the most widely used column family database management system is Apache Cassandra, and Azure Cosmos DB actually supports the column family approach through its Cassandra API. Now, a graph database stores two types of information. So there is nodes and edges. Nodes you can think of as an instance of an entity, and edges specify the relationship between nodes. So both nodes and edges can have properties that are used to describe the relationship between one another. Additionally, edges can also have a direction indicating the nature of the relationship. So the purpose of a graph database is to enable an application to perform queries quite efficiently by traversing the network of nodes and edges to analyze the relationships between the nodes or between the entities. If we take a look at an example, let's imagine that we are representing all the employees in an organization with the graph database or graph model. And so each node represents an employee, and the edges represents the reporting line for each of the employees. And so in this graph, the arrows on the edges show the direction of the reporting line. So with this structure, this kind of graph model and database, we can ask questions like find all the employees who report to the IT manager, for example, or we can ask questions like find out who works in the same department as me. So for large graphs with lots of entities and relationships, you can perform these very complex queries quite quickly. And so we can use graph databases to traverse the network of relationships and help provide answers to those type of complex queries. In SQL, how you would normally do these kind of queries is that you might have to do a lot of recursive joins, operations, and nested subqueries, which can actually become very, very expensive and slow to do. So Azure Cosmos DB supports graph databases through the Gremlin API. The Gremlin API is a standard language for creating and querying graphs. Lesson 5, exploring concepts of data analytics. So data analytics is concerned with taking the data that your organization produces and using it to establish a picture of how your organization is performing and what you can do to either improve or maintain that performance. So data analytics helps you to identify both strengths and weaknesses in your organization, and it helps you make the best business decisions based on some of the results. So the data that a company might use can come from many sources. Now, in a data analytics solutions, you would typically combine all this data from your many sources and construct a data warehouse where you can then use it to ask questions about your business operations. Building a data warehouse will require you to capture the data that you need and transform it into an appropriate format for you to do those kind of querying and data analytics workloads. You can then use visualization tools to examine the information presented by your data and help identify trends, issues, problems, causes to your organization. Now, typically, to start the data analytics process, we begin with data ingestion. So data ingestion is the process of obtaining and importing data for immediate use, or we can store it in a database. So during the data ingestion process, data could be ingested through a continuous stream, or it could come in batches. The purpose of the ingestion process is really to capture this data and either process it immediately or store it. So during the ingestion process, we might do some filtering. For example, if we are ingesting data that could come from a suspicious, corrupt, or data source. And so suspicious data might be data that is coming from an unexpected data source. Corrupt or duplicated data could be due to some device malfunctioning, or there might be transmission failures, or someone might be tampering with the data. During this stage, it's also possible to do some transformation to the data. So we can convert some of that data to a more standardized format for processing later. So for example, if we're talking about dates and times, we might want to reformat it so that all the data that's been ingested will use the same date and time representation. Or if we're talking about measurement data, for example, we might want to convert it so that they all conform to the same metrics. But if we're doing transformation at this stage, remember to keep them quick. Don't want to run any complex calculations or aggregations during the data ingestion stage. If you do need to, then store the data first and we'll come and process it later. Which leads me to data processing. So the data processing stage generally occurs after the data has been ingested and or collected. So data processing takes the data in its raw format and it cleans it, converts it into a more meaningful format that can then be stored in tables or graphs or document databases and so on and so forth. So the results can then be used to perform queries and generate visualizations to be consumed by employees throughout the organization. Now, the aim of data processing is really to convert the raw data into a business model. So a business model describes the data in terms of meaningful business entities, and we might want to aggregate some stuff together to summarize information. So the data processing stage, we could also use it to generate predictive and analytical models from the data. Data processing can actually be quite complex. So it might involve automating a lot of scripts. You might have to use tools like Azure Databricks, Azure Functions, Azure Cognitive Services to examine and reformat the data and generate those models. So a data analyst could then use machine learning to help determine future trends based on the models that's been created from the data. Now, the data processing mechanism can take two approaches to retrieving the ingested data and processing this data to transform it into one of these business models and then saving the transform data and models. So these two approaches are known as ETL and ELT. ETL stands for extract, transform, and load. So the raw data is retrieved and transformed before being saved. So during the transform stage, the data might get standardized, clean, transformed, aggregated. Some of the missing values could be filled out, corrupt data could be chucked out. Other tasks could involve some basic data cleaning, deduplicating data, and reformatting some of the contents of the data. So once the data is in a standardized format that is suitable for analytics, it gets loaded into a repository system. The extract, transform, and load steps can be performed as a continuous pipeline of operations. So ETL is quite suitable for very simple and basic models that has very little dependency between items. The alternative approach to ETL is ELT. So ELT is short for extract, load, and transform. So this process is slightly different because the data is first stored before it's transformed. So the data processing engine can take an iterative approach by retrieving and processing the data from storage before writing the transformed data and models back to storage. Now, ELT is more suitable for constructing complex models that depend on multiple items in the database, often using periodic batch processing. ELT is also a more scalable approach that is suitable for cloud workloads because it can make use of the extensive compute power of the cloud. So ELT is more stream orientated than ETL, because with ETL we can filter the data before it's stored, which is good for data privacy and compliance, as we can remove any sensitive data before we store it. However, ELT, we can't do that because we load the data before we transform it and process it. So Azure provides a couple of options for you to implement both ETL and ELT. So for example, if you're storing data, you can store data in an Azure SQL database, and then you can use the SQL Server integration services to build out your ETL and your ELT pipelines. The SQL Server integration services can extract and can transform data from a whole range of sources, such as XML data files, flat files, relational data sources, and then load the data into one or more destinations. Another approach is to use Azure Data Factory. So Azure Data Factory is a cloud-based data ingestion service that allows you to create those data-driven workflows and pipelines for orchestrating data movements and transforming data at scale. So with Azure Data Factory, you can create and schedule data-driven workflows, also called pipelines, that can ingest data from a lot of different data sources. And you can build quite complex ETL processes that transforms data visually with data flows. Or you can use other compute services like Azure HD Insight, Azure Databricks, Azure SQL Database to do some of that transformation as part of the pipeline. Once we process our data, we've gathered insights and results from our analytics and queries, we can visualize the information that our business models we've built present using data visualization tools. So to start the visualization piece, we generally start with creating reports to report on some of our findings and results. So reporting is the process of organizing data into informational summaries to monitor how different areas of an organization is performing. So reporting helps companies, for example, monitor how their online business is doing. They can find out what's not performing well. Good reporting should actually raise questions about businesses from its end users. And using reporting, we can find out things that's happened, and then we can use analysis to explain why certain things happened and what we can do about it. Now, business intelligence, or BI, refers to technologies, applications, and practices for collecting, integrating, analyzing, and presenting business information back to the organization. So the main goal or purpose of business intelligence is really to support better decision making. Now, business intelligence systems can provide historical, current, and predictive views of the business operations. And often they can use data that's been gathered in a data warehouse, or they could use data that's from live operational data systems. So some of the things that they might be able to do is present an interactive slice and dice pivot table analysis, visualize that data, or do some statistical data mining with the data. So we could also create application as part of the business intelligence process to tackle particular areas in the organization, like sales or production or financial, to really track how the business is performing against the industry and against the market. So data visualization helps you to focus on the meaning of data rather than looking at the data itself. So a good data visualization enables you to quickly spot trends, anomalies, and potential issues. Some of the common forms of visualizations that you might use include bar and column charts, line charts, matrices, key influences, tree maps, scatter plots, a bubble chart, or a field map. So with bar and column charts, they allow you to see how a variable changes across different categories. With line charts, we can see how the overall shape of the values are doing over a period of time. With matrices, these are generally a tabular structure that summarizes data. And so often report designers use matrices in reports or dashboards to allow the user to select a particular component and see its significance across the data. Key influences are charts that displays, who the major contributors to a particular result or value is. So key influences are great for understanding, what particular factors influence a specific key metric. Tree maps are used as charts of colored rectangles, so that the sizes of the rectangle generally represents the relative value of that item, and so they can be hierarchical. So rectangles can also be nested within other rectangles. Scatter plots or scatter charts can be used to show the relationship between two numeric values, and a bubble chart is essentially a scatter chart that replaces the data points with bubbles, and so the bubble size represents its relative data points in the data. And a field map is, if you've got geographical data, you can actually use a field map to display how a value differs in proportion across a geography or region. And so you can see the relative differences with shadings that range from light, which generally means less frequent, or lower, to dark, which means more frequent or more. Now, just to wrap up on data analytics. So data analytics is really about examining, transforming, and arranging data so that you can study it and extract useful information out of your data. You can often categorize data analytics as descriptive, diagnostic, predictive, prescriptive, and cognitive. So descriptive analytics is all about asking and answering questions like, what is happening in my business? So descriptive analytics helps you answer questions about what has happened based on historical data. It uses techniques to summarize large data sets to describe outcomes to stakeholders. So examples of descriptive analytics includes generating reports to provide a view of an organization's sale and financial data. With diagnostic analytics, this is really used to answer questions like, why is this happening to my business? And so with diagnostic analytics, we generally use it to help find out what the root cause of something is, why something had happened. And it's really about taking the findings from descriptive analytics and diving a little deeper to find out the cause. And so generally in diagnostic analytics, we take 3 steps to this approach. So we identify the anomalies in the data. So these could be unexpected changes in the metric or particular market. Then we collect data that's related to these anomalies. And then we use statistical methods to discover relationships and trends that could explain these anomalies. In predictive analytics, this is all about trying to find out quick answers to questions like, what is likely to happen in the future based on previous trends and patterns? So predictive analytics is really used to help answer questions like, what will happen in the future? We can use techniques that uses historical data to identify trends and determine if it's likely to reoccur. And some of these techniques includes things like statistical and machine learning techniques, such as neural networks, decision trees, and regression. And with prescriptive analytics, this is really used to help answer questions about what actions needs to be taken to achieve a particular goal or target. So by using insights from predictive analytics, data-driven decisions can be made. So prescriptive analytics allows business to make informed decisions in the face of uncertainty. So with prescriptive analytics, we can rely on machine learning strategies to find patterns in a large data set. And we can also analyze past decisions and events that's happened and figure out what the likelihood of it being happened again or likelihood of different outcomes that could happen. And finally, cognitive analytics. Now, this type of analytics is inspired by how the human brain works. So how we process information, how we draw conclusions, how we codify instincts and experiences into learning and understanding. So cognitive analytics really attempts to draw inference from existing data and patterns, derive conclusions based on existing knowledge bases, and then add these findings back into the knowledge base for future inferences. So this is a self-learning feedback loop. So cognitive analytics really helps you to learn what might happen if circumstances change and how you might handle these situations differently. And that's it for Module 1. So we just had a look at some core data concepts, relational data, non-relational data, and data analytics concepts as well. So let's take a 10-minute break, and I'll see everyone back here in 10 minutes to start Module 2. So now we're going to take a look at Module 2, where we're going to explore some of the relational data services in Azure. So we're going to take a look at things like SQL databases, PostgreSQL, MySQL, MariaDB, and we're going to look at how to provision and deploy relational data in Azure, as well as how we can query relational data in Azure. So let's get started with Module 2. Lesson 1, Explore Relational Data Offerings in Azure. So what are some of the Azure Relational Data Services? Well, we've got SQL Server on Azure Virtual Machines, we've got Azure SQL Managed Instances, and Azure SQL Database. So Azure offers a range of options for running a database management system in the cloud. For example, you can migrate your on-premises systems to a collection of Azure Virtual Machines. This approach still requires you to manage your database management systems under the hood. Alternatively, you can take advantage of the various Azure Relational Data Services available. So these data services actually manage the database management system layer for you, which means you can really just concentrate on the data that will be consumed by your applications. Now, before we dive into the Azure Data Services a little bit more, let's just talk about some of the common terminologies that we might be using, as well as the different ways that you can host a relational database in Azure. So Infrastructure as a Service, or IaaS, generally describes services where Azure enables you to create a virtual infrastructure in the cloud that mirrors the way that an on-premises data center might work. So you can create a set of virtual machines, you can connect them together using a virtual network, and you can add a range of virtual devices to the network. So you still need to be responsible for installing and configuring the software, such as the database management systems on these virtual machines. So in a lot of ways, this approach is quite similar to the way that you would typically run your database management systems on premises within your organization, except you don't have to buy or maintain hardware anymore. Platform as a Service, or PaaS, are services where rather than creating a virtual infrastructure and installing and managing the database software yourself, a PaaS solution does this for you. So you specify the resources that you require based on how large you think your databases will need to be, how many users will be using them, the performance requirements that you need, and Azure automatically creates the virtual machines, networks, and other devices for you. You can also scale up and down, increase or decrease the number of resources quite quickly as well. So as the volume of data or the amount of work that you need to do grows, you can easily scale according to the growth of your workload. And Azure will automatically handle the scaling for you so that you don't have to go and manually add or remove virtual machines or perform any other types of configuration. Now, Azure Data Services generally fall into the PaaS category. So these services are essentially a series of database management systems managed by Microsoft in the cloud in Azure. So with each of these data services, Microsoft takes care of the configuration, the day-to-day management, software updates and security of the databases that it hosts, as well as all the other administrative tasks. So all you have to do is really create the database, and then they will be managed and looked after by the Azure Data Service. Now, the most well-known one is the Azure SQL database. Others include Azure Database for MySQL, for MariaDB, and PostgreSQL. Now, while the Azure Data Services helps you reduce the amount of time that you need to invest into administrating a database management system, these services also come with some limitations in terms of the custom administration tasks that you can perform to them. So, for example, some database management systems allows you to install custom software into a database, or you can run scripts as part of the database operation. Now, in PaaS, this might not be supported because allowing these scripts to run in the database means we have to expose the security of the data servers. So that's going to expose the data servers to potentially some security vulnerabilities and concerns. So you must be prepared to work with some of these restrictions in mind when you're working with Azure Data Services. Now, apart from reducing the administrative workload, Azure Data Services ensures that your databases are highly available at least 99.99% of the time. What that means is that they're guaranteed to be up and running at least 99.99% of the time. Although Azure Data Services is actually much cheaper in comparison to the IaaS option, there are still costs associated to running an Azure PaaS data service, because there is a base price which covers the underlying infrastructure, licensing, administrative charges, and additionally, Azure Data Services are designed to be always on. What that means is you can't stop it running for a set period of time and restart it again later, unlike Azure Virtual Machines. So you have no direct control over the platform on which these data services run on. If you do need more control than what the Azure Data Services offers you, you can install your database management system to an Azure virtual machine. Now, Microsoft SQL Server has been traditionally quite a popular relational database management system. Has a long-running history with a lot of features that provide database management systems to organizations of all shapes and sizes. And so in the past, a lot of organizations have been running SQL Server on premises. But a lot of organizations these days are actually looking at shifting this operation to the cloud. And so there are a couple of ways that you can run SQL Server in Azure. So SQL Server on an Azure virtual machine enables you to run a full version of SQL Server in the cloud without having to manage any on-premises hardware. So this is that IaaS approach. You can use SQL Server in an Azure virtual machine to develop and test your traditional SQL Server applications. With an Azure virtual machine, you have the full administrative rights over the database management system and the operating system. So it's a perfect choice if your organization already has IT resources to maintain and manage virtual machines. And so what that means is you can create very rapid development and testing scenarios using Azure virtual machines without having to buy on-premises SQL Server hardware for non-production workloads. You can also lift and shift existing applications that require very fast migration to the cloud with minimal changes or virtually no changes at all. And you can also scale up on the Azure platform where your SQL Server is running by allocating more memory, more CPU power, more disk space on the Azure virtual machine as you need it. So you can quickly resize an Azure virtual machine without the requirement of having to reinstall the software that is running inside those virtual machines. So You have three options to deploy a SQL Server to an Azure virtual machine. There are some pre-installed SQL Server on Windows and Linux virtual machines in Azure, which you can access through the marketplace. You can also install your own SQL Server to an Azure virtual machine. You can lift and shift your on-premises SQL databases using Azure Migrate and Azure Site Recovery. How SQL Server on Azure Virtual Machine might benefit you is you've got greater access to licensing and additional flexibility in the cloud. Some of the backups can be automated and you can apply security updates to your databases as well. You can also manage your SQL servers through the Azure Virtual Machine as long as you can connect to your virtual machines. Now, in terms of sizes, storage, and performance, you get to choose between memory or storage options to optimize your databases for better performance. You can store your data and logs on premium managed disk storage. You can use ultra disk storage for low latency access, and your temporary database can actually be stored on local solid-state drive disks. In terms of network and security, you can integrate your Azure Virtual Networks with your on-premises network so that your SQL Server databases can actually communicate back on premises with the applications that might still be on premises. You can access advanced data security services in the cloud. And in terms of HA&DR, which means high availability and disaster recovery, you can configure high availability for your Azure virtual machines using either availability sets or availability zones. You can also use some of the redundancy options to configure disaster recovery for your storage. You can easily make backups of your databases using some of the Azure backup services. And with HA&DR configured, you can easily fail over when one of your or more databases go down. Now, if you don't want to incur the management overhead costs associated with running a SQL Server on an Azure virtual machine, you can use Azure SQL Database. So Azure SQL Database is a PaaS offering from Microsoft. You create a managed database server in the cloud and then deploy your databases to the server. So when you use Azure SQL Database, you actually need to create an Azure SQL Database server first. So this SQL Database server is actually a logical server that acts as a central administrative point for a single, multiple, or pool databases, logins, firewall rules, auditing rules, threat detection policies, and failover groups. So Azure SQL Database is available in a couple of options. You can have a single database, elastic pool, and managed instance. Now, Azure SQL Database gives you the best option for low cost with minimal administration, but it's not fully compatible with some of the on-premises SQL Server. So typically, Azure SQL Database is considered when building out new cloud projects where the application design can accommodate to these kind of changes to your database tier. So Azure SQL Database, it's often used for modern cloud applications that need to use the latest stable SQL Server features, applications that require high availability, and systems that have a variable load. So if your database server needs to scale up and down very, very quickly, Azure SQL Database is able to support that. Now you might be wondering, what else does Azure SQL Database take care of? Well, Azure SQL Database automatically updates and patches the SQL Server software for you and ensures that you're always running on the latest and most secure version of SQL Server. Azure SQL Database can also scale your resources up and down depending on your requirements without you having to perform any manual interventions. Azure SQL Database also provides high availability guarantees to ensure that your databases are available at least 99.99% of the time. Azure SQL Database also supports point-in-time restore, which means you can recover your database to some particular state or point of time in the past. You can also choose to replicate your Azure SQL databases to any one of the 60 plus global Azure regions across the world to provide that additional assurance and disaster recovery. Azure SQL Database also comes with advanced threat protection. So advanced threat protection provides advanced security capabilities like vulnerability assessments to help detect and remediate potential security problems with your databases. It also can be used to detect anomaly activities. So that could indicate unusual or potentially harmful attempts to access or exploit your databases. With advanced threat protection, you can also use it to continuously monitor your databases for suspicious activities and provide immediate alerts on any potential security incidents like SQL injection attacks. And the alerts can also provide details on the suspicious activities as well as recommendations on how to investigate and mitigate those threats. You can also audit your database events and write audit logs to an Azure storage account. So auditing can help you maintain regulatory compliance, understand database activity, and gain insight into discrepancies and anomalies that might indicate potential security violations. So Azure SQL Database can also help secure your data by providing encryption. So for data in motion, it uses the transport layer security. For data at rest, it uses transparent data encryption. And for data in use, it uses always encrypted. So you can be sure that your data is always safe and protected. Now, a business might also want to eliminate the management overhead costs as much as possible from having to administer databases and server, but because of some of the limitations of Azure SQL databases, Azure SQL Database might not be the best option for them. And so in these kind of situations, Azure SQL Database Managed Instance is an alternative to consider. So Managed Instance effectively allows you to run a fully controllable instance of SQL Server in the cloud. So you can install multiple databases on the same managed instance. You have complete control over this instance, same as you would on premises. The managed instance service automates things like backup, software patching, database monitoring, and other general tasks that you would need to do on premises, but you still have full control over the security and resource allocation for your databases. So managed instance depend on a lot of other different Azure services like Azure Storage for backups, Azure Event Hubs for telemetry, Azure Active Directory for authentication, Azure Key Vault for transparent data encryption, and a couple more other Azure services that provide those security and supportability features. So the managed instance is essentially a setup of all these services that has already been done for you to really help relieve some of those administrative efforts so that you don't have to do it. Now, all communications are encrypted and it uses certificates. So to check the trustworthiness of a communicating party, managed instances constantly verify the certificates through a certificate revocation list. So if the certificates are revoked, the managed instance will close the connection to protect the data. Now, managed instances has near 100% capability with SQL Server Enterprise Edition running on premises. So if you want to lift and shift your on-premises SQL Server to the cloud without incurring those management overhead costs of running a SQL Server on an Azure virtual machine, then you should really consider using Azure SQL Database Managed Instance. Now, Azure SQL Database Managed Instance also provides features that's not available in Azure SQL Database. So if your system uses features such as linked servers or a service broker, which is a message processing system that can be used to distribute work across the servers, or a database mail, which enables your database to send email messages to users, you should also consider using Azure SQL Database Managed Instance. If you want to check the compatibility with your existing on-premises SQL Server, you can install the Data Migration Assistant tool. And this tool will help analyze your databases on premises and report any issues that could block this migration to a managed instance. Now, when it comes to both Azure SQL Database Managed Instances and Azure SQL Database, typically there are two options. There's what's called the single and the pool option. So a single database or a single instance, this option allows you to quickly set up and run a single SQL database server, and you can create and run a database server in Azure and access your database through the server. So Microsoft will manage the server so that all you have to do is configure the databases, create those tables, populate them with data, and you can scale the database with more storage or memory or processing power, CPU, if you need it. By default, the resources are pre-allocated, and so you're charged per hour for the resources you requested. You can also specify a serverless configuration. So with the serverless configuration, Microsoft will create the server for you, but this might actually be shared with other databases belonging to other Azure users. However, Microsoft will ensure the privacy of your database. So although the resources are shared amongst other users, your data inside your database is still kept private and only accessible to you. So your database can also automatically scale up and down with the resources allocated as you need it. Now with the elastic pool option, this is similar to that single database option, except by default, multiple databases can share the same resources like memory, storage, and processing power. And these resources are referred to as a pool. So you can create the pool and only your databases can use this pool. So it's not shared amongst other Azure users. And this model is actually quite useful if you have databases with resource requirements that can change or vary over time, and it can help you reduce costs. So for example, you might be running a payroll database that might require a lot of CPU power at the end of the month as you handle this payroll processing. But at other times, when it's not handling those payroll processing, the database might be less active. And so you can have another database being used to run other operations using those kind of resources. Now, your payroll database during that payroll processing period might become active for a couple of days to process those payrolls, and at other times it might not need it. And so with Elastic Pool, what this allows you to do is essentially scale the resources as your databases needs them and release the resources when the processing is complete and allocated to other databases that might need it. Now, as well as Azure SQL Database, Azure Data Services also offers other database services for some of the other relational databases in the market. For example, PostgreSQL, MySQL, and MariaDB. The primary reason for these services is really to enable organizations that are already running PostgreSQL, MySQL, or MariaDB to move to Azure quite quickly without having to make a lot of changes to their applications. So PostgreSQL, MariaDB, and MySQL, they're all relational database management systems, each with their own special tailored features. So PostgreSQL is a hybrid relational object database. You can store data in relational tables, but a PostgreSQL database can also enable you to store custom data types with their own non-relational properties. So the database management system, it's extensible, so you can add code modules to the database, which can be run by queries. Another key feature of PostgreSQL is it's got the ability to store and manipulate geometric data. So these are things like lines, circles, polygons. PostgreSQL has its own querying language called PGSQL, and this language is sort of a variant of the standard relational query language SQL. And there's features inside PostgreSQL that allows you to write your own store procedure and run them inside a PostgreSQL database. Now, MySQL started off as a simple to use open source database management system. And it comes in a couple of editions. So there's the Community Edition, Standard Edition, and Enterprise Edition. The Community Edition is free, and that's why it's been sort of a popular database management system for a lot of web applications. And under the hood, it runs on Linux. So there are some versions available for Windows as well. Now, the Standard Edition offers higher performance and uses a different technology stack for storing data. The Enterprise Edition provides a more comprehensive set of tools and features, including enhanced security, availability, and scalability. So the Standard and the Enterprise Editions are generally the ones that are used by commercial organizations because those versions are not free. Now, MariaDB is a newer database management system that's been created by the original developers of MySQL, actually. So the database engine has since been rewritten and optimized to improve performance. So MariaDB offers compatibility with Oracle database, which is another popular commercial database management system. And one notable feature of MariaDB is it has inbuilt support for temporal data. So a table can actually hold several versions of data, which enables an application to query data as it appears at some point in the past. So Azure MySQL Database is based on the MySQL Community Edition. The Azure MySQL Database service includes high availability at no additional cost and scalability as you require it. So you only pay for what you use, and backups are automated with point-in-time restores up to 35 days in the past. The server also provides connection security, which enforces firewalls and optionally requires SSL connections. Many server parameters also enable you to configure the server settings so that you can enable lock modes, maximum number of connections, and timeouts. Now, the Azure MySQL database provides a global database system that scales up to large databases without the need for you to manage any hardware, any network components, virtual servers, patch any software, and any of those things. So there are some operations in Azure MySQL database that are not available. And these are usually because of that security component. So these limitations are usually if you want to do any customization to your Azure MySQL database, which could lead to potential security vulnerabilities. Benefits for MariaDB is almost exactly the same as MySQL. Now, if you prefer Azure PostgreSQL, you can choose Azure Database for PostgreSQL. So this service provides the same availability and performance, scaling, security, and administrative benefits as the Azure MySQL service. Again, some of the features that you might find within on-premises PostgreSQL database are not available in the Azure PostgreSQL database service. So these features are mainly concerned with extensions that users can add to a database to perform specialized tasks, such as writing store procedures in programming languages other than PGSQL, and interacting directly with the operating system. Now, Azure PostgreSQL has two deployment options you can choose from. So you can have a single server or a hyperscale. So with single server, the single server deployment option for PostgreSQL provides similar benefits as the Azure MySQL database. You choose from 3 pricing tiers, so basic, general purpose, and memory optimized. Each of these tiers supports different numbers of CPU, memory, and storage sizes, so you can select the one that matches your workload requirements. Now, the hyperscale option is a deployment option that scales queries across multiple server nodes to support large database loads. So your database is split across multiple nodes. These data is split into chunks based on the value of a partition key or a sharding key. So you should consider using the hyperscale option for very large databases with PostgreSQL deployments in Azure. Some of the benefits for Azure PostgreSQL database is that it's highly available and it contains built-in failure detection and failover mechanisms. Now, users of PostgreSQL might be familiar with the PG admin tool, which is a tool that is used to manage and monitor PostgreSQL database. And so you can continue to use this tool to connect to your Azure PostgreSQL database as well. Lesson 2, exploring, provisioning, and deploying relational database offerings in Azure. Now, what exactly is provisioning? Well, when a user specifies that they want to provision something, they need to specify the provisioning parameters, such as the type of servers, storage, memory, and compute power. These provisioning parameters are then sent to Azure to provision the service, and then Azure allocates the necessary resources to create the service. Now, once the service has finished provisioning, then the service is actually ready to use and the user can start to consume the service. So the process for provisioning Azure SQL Database is quite similar across Azure SQL Database, Azure MySQL Database, Azure PostgreSQL Database, and Azure MariaDB Database. So you have to provide a couple of the provisioning parameters, and we usually start with the Basics tab. So in the Basics tab, we specify a couple of the settings like subscription. So an Azure subscription is essentially a billing account attached to your Azure accounts. We also have to specify the resource group. So you can either put your database in an existing resource group or create a new one. A resource group is just a logical container for your Azure resources. You also need to specify the server name. So each database server must have a unique name that hasn't been used by someone else. The name typically needs to be between 3 to 31 characters long and usually contains only lowercase letters, digits, and hyphens. You also can choose to specify the data source. And so if you choose none, it means you're creating a brand new database, or if you select backup, you are creating a server from an existing database. In the location, you need to choose the region to deploy that database server and database to. And so typically you would choose a region that is closest to you or closest to your user. And an Azure region is essentially one or more Azure data centers in the geolocation where your resources are being deployed and hosted out of. In the compute and storage parts, you need to specify the compute, storage, and backup configurations for your new server. And typically, this is bundled up into what's called DTUs, or database transaction units. And for the pricing tier, there's typically 3 pricing tiers you can choose from. So the basic pricing tier is generally for those that require light compute and very light input-output performance, and they're typically reserved for very small-scale development, testing users. The general-purpose pricing tier, so this pricing tier is for business workloads that require balanced compute and memory with scalable I/O throughput. So examples include servers for hosting web and mobile apps and other enterprise applications. And then there's the memory optimized pricing tier. Now this tier supports high performance database workloads that require in-memory performance for faster transaction processing and higher concurrency. So some examples might be servers that processes real-time data and high-performance transactions or analytical apps. So you can fine-tune the resources for each of the selected tiers. You can also scale it up if you need to later on. Typically, when you provision data services, you also need to give it some credentials. And so this involves an admin username and a password. So with this, we create a sign-in account where you can use it to connect to your server. Now, the admin sign-in name can't contain words like admin, administrator, root, guest, or public. So you should pick an admin username that has some meaning for your data server. And there are some limitations to the password part as well. So you need to choose, the password needs to contain characters that's between 8 to 128 characters in length. It needs to have characters from a lowercase, uppercase letter. It needs to contain a digit and some non-alphanumeric character as well. And after you've specified all these settings, you can then go and create, which will then provision the data server for you. There are also additional settings and network connectivity settings that you can specify as well upon provisioning your databases, but you can also go and modify and update these settings once you've provisioned your databases and your data servers. Now, Azure SQL Database communicates over port 1433. So if you're trying to connect from within the corporate network, sometimes outbound traffic over port 1433 might not be allowed by your network's firewall. So if that's the case, you won't be actually able to connect to your Azure SQL Database server unless your IT department opens up port 1433. Now, the default connectivity for Azure Relational Data Services is actually disabled across the world. So if you need to connect the service to the service from an on-premises computer or machine, in the firewall section, you need to actually add the IP address range of the computer or machine trying to connect to the Azure Data Service. Now, a firewall rule of 0.0.0.0 enables all Azure services to pass through the server level firewall rule. So if you wanted to open up your data service to the world, you can also specify this range to be between 0.0.0.0 to 255.255.255.255. However, keep in mind that you shouldn't actually do this for any production workloads and only allow access for the machines and applications that needs to access your databases. Otherwise, you'll be exposing yourself to a lot of security vulnerabilities on the network. Now, if we take a look at this diagram here, so we've got a client connecting to the database gateway, which has a public IP address and is listing on port 1433. Now, this gateway, depending on what connection policy has been specified on this gateway, will either redirect or proxy the traffic to the right database tier in the backend. And so then inside the database cluster tier, the traffic is then forwarded to the appropriate database. You can specify 3 types of server connection policies. So there is the redirect connection policy, which is the recommended one. The redirect one will allow a client to establish connections directly to the node that's hosting the database, which means there is lower latency and higher throughput. Now, for connections to use this kind of connection policy mode, the client needs to allow outbound communication from the client to all Azure SQL IP addresses in the region on ports in the range of 11000 to 11999. We can also use service tags for SQL to make this easier to manage. And so service tags is essentially a group of IP address ranges that's specific to a particular Azure product or service. Now, it also needs to allow outbound communication from the client to the Azure SQL Database Gateway IP address on port 1433. The other connection policy mode that you can choose from is the proxy mode. So in this mode, all connections are proxied via the Azure SQL Database Gateway, which means there is a bit more latency and reduced throughput. And for connections to use this mode, the client needs to allow outbound communication from the client to the Azure SQL Database Gateway IP address on port 1433. And the third connection policy mode is the default one. So this is the connection policy that's established by default unless you explicitly alter the connection policy to either proxy or redirect. Now, the default policy will redirect for all client connections originating inside of Azure. So say, for example, if you're trying to connect to your Azure SQL database from an Azure virtual machine, and it will proxy all client connections originating outside of the Azure network. So for example, if you're trying to connect to your Azure SQL database from an on-premises network. So we highly recommend using the redirect connection policy over the proxy connection policy for that lower latency and higher throughput. But if you need to meet additional requirements for allowing network traffic, you can also use the proxy connection mode to do so. If the client is an Azure virtual machine, you can accomplish this using network security groups or NSGs using service tags as well. So if the client is connecting from within a on-premises workstation, then you may need to work with your network admin to allow network traffic through the corporate firewall. If we're trying to connect from within Azure, your connections need to have a connection policy of redirect by default. So a policy of redirect means that after the TCP session is established to the Azure SQL database, the client session is then redirected to the right database tier with a change to the direction to the destination virtual IP from that of the Azure SQL database gateway to that of the cluster. And then after that, subsequent packet flows will be directed to the cluster, bypassing the Azure database gateway. Now, if we're connecting from outside of Azure, your connections will have the proxy connection policy by default. So a policy of a proxy means the TCP connection, once the TCP connection is established via the Azure SQL database gateway, all the subsequent packets will flow via the gateway.
So when it comes to network security for SQL databases, we can configure a couple of things like which services to allow to access our SQL database. So we can do that through firewall rules or setting up virtual network rules or using private link. So let's say we wanted to lock down the traffic to our Azure SQL databases and block off public internet access to these SQL databases. So using private endpoint, we can block off public internet access to our Azure SQL database so that the only connection it has is a private endpoint, which is part of the Azure Virtual Network that Azure SQL database talks to. So with Azure Private Endpoint, this is a network interface that allows you to privately and securely connect to Azure services through a private link. So private endpoint uses a private IP address from your virtual network so that it effectively brings that service into your virtual network. Now, we can also use things like VPN gateway or ExpressRoute to connect our on-premises environment to our Azure Virtual Network. And then we can block off all the public internet access to our Azure SQL database. So this setup allows our on-premises environment to connect to our Azure SQL databases running in Azure over that private IP address space. We can also use VNet pairing to pair multiple virtual networks together so that essentially we can treat them like one, and so that resources can communicate with one another over that private IP address space as well.
With Azure Active Directory authentication, you can centrally manage the identities of database users and other Microsoft services in one central location. So central ID management provides a single place to manage database users and simplify permission management. So you can use these identities and configure access to your relational data services. Some of the benefits of doing so is that it provides an alternative to SQL Server authentication. It allows for password rotation in a single place. Customers can also manage database permissions using external Azure AD groups. You can also eliminate storing passwords by enabling integrated Windows authentication. Azure AD authentication uses contained database users to authenticate identities at the database level. Azure Active Directory also supports token-based authentication for applications connecting to SQL database and SQL managed instances. And Azure Active Directory also supports multi-factor authentication, which means you can include strong authentication from a bunch of verification options like phone calls, text messages, smart cards, pins, or a mobile app notification. You can also authenticate users connecting to Azure PostgreSQL database or Azure MySQL database through Azure Active Directory as well. So Azure Active Directory enables you to specify who and what can access your resources. And these access controls will define what a user or an application can do with your resources once they've been authenticated. So access management for cloud resources is a critical function for any organization that is using the cloud. So Azure Role-Based Access Control, or Azure RBAC, helps you manage who has access to Azure resources and what they can do with those resources. So for example, using RBAC, you could allow a user to manage virtual machines in a subscription and allow another user to manage virtual networks, or you could allow a user to be the database administrator so that they can manage SQL databases in a subscription and allow another user to manage all resources in the resource group, like virtual machines, websites, and subnets. And you could also use it to allow an application to access all the resources in the resource group. So you can control access through resources using Azure RBAC by creating role assignments. And so a role assignment consists of 3 elements. It consists of a security principle, role definition, and a scope. So a security principle is an object that represents a user, a group, a service principal, or a manager identity that is used to request access to a particular Azure resource. A role definition, often just called a role, is a collection of permissions. And a role definition lists the operations that can be performed, such as read, write, delete. Roles can be given quite high-level names like owner or virtual machine reader. Azure includes a couple of built-in roles that you can use. So the owner role has full access to all the resources, including the right to delegate access to others. The contributor role allows you to create and manage all types of Azure resources, but you can't grant access to others. The reader role will allow you to view existing Azure resources, but you can't modify, update, or delete any resources. And the user access administrator role allows you to manage user access to your Azure resources. Now, a scope lists the set of resources that the access applies to. So when you assign a role, you can further limit the actions allowed by defining a scope. This is quite helpful, for example, if you want to make someone a website contributor, but only for one resource group. So similar to Azure SQL databases, you can also replicate data for Azure PostgreSQL database or Azure MySQL database to read-only service. So Azure PostgreSQL database supports replication from the master server up to 5 replicas. So replicas are updated asynchronously with PostgreSQL engine's native replication technology. The read replicas help to improve the performance and scale of read-intensive workloads. So read workloads can be isolated to the replicas, while the write workloads can be directed to the master. Common scenario where you might use this is if you've got analytical workloads that uses the read replica as a data source for reporting. Because the replicas are read-only, they don't directly reduce the burden of write operations on the master. Now, this kind of replica feature isn't targeted for write-intensive workloads. So replicas are new service that you need to manage, similar to regular Azure databases. So for each replica, you're actually billed for the provision compute in virtual cores and storage in gigabytes per month. Now for Azure MySQL database, similar to the Azure PostgreSQL database, you can again create up to 5 read replicas for your MySQL database. And this feature enables you to geo-replicate data across regions and distributes the overhead associated with read-intensive workloads. So replication is asynchronous from the master server, so there might be some lag between when records are written to at the master to when it becomes available across all the replicas. Just remember though, re-replication isn't intended to support write-heavy workloads. So this concludes the first part of Module 2. Let's go take another 10 minutes break and we'll continue to explore Module 2 after the break. So I'll see everyone after the break. Welcome back from the break. So let's continue exploring Module 2, where we're going to have a look at querying relational data now in Azure. So let's get started. Lesson 3, querying relational data in Azure. So let's have a look at what SQL is. SQL stands for Structured Query Language. SQL is used to communicate with a relational database. It's the standard language for relational database management systems. So SQL statements are used to perform tasks like updating data in a database, retrieving data from a database. Some of the common relational database management systems like Microsoft SQL Server, MySQL, PostgreSQL, MariaDB, and Oracle all uses a variant of SQL. Now, just a bit of a fun history. SQL was originally standardized by the American National Standards Institute in 1986. And by the International Organization for Standardization in 1987. Since then, the standard has been extended several times as relational database vendors have added new features to their systems. Additionally, most database vendors have included their own proprietary extensions that are not part of the SQL standard, which has resulted in a variety of dialects of SQL.
So when it comes to SQL statement types, there are 3 categories you should know about. First one being DML, or Data Manipulation Language, DDL, or Data Definition Language, and DCL, Data Control Language. Now, DML, or Data Manipulation Language, are the statements that are used to query and manipulate data. So they're statements like select, insert, update, and delete. DDL, or Data Definition Language, is used to define database objects. So they're statements like create, alter, drop, and rename. DCL, or Data Control Language, are statements used to manage security permissions. So they're things like grant, revoke, and deny. So you can use DML statements like select, insert, update, delete to basically accomplish anything you want in the database. Now, select allows you to read and retrieve particular data rows or data items from a table. Insert allows you to add a data row or data items to a table. Update allows you to modify or change existing data in a data row or data item in the table. And delete allows you to remove a particular row item or data row from a table. Now, although a lot of these SQL statements are part of the SQL standards, many database management systems also have their own additional proprietary extensions to handle specifics of that database management system. So these extensions are not covered by the SQL standards, and they include things like security management and programmability. So these proprietary extensions can include things like store procedures, triggers, and managing user accounts. So PostgreSQL and MySQL have their own versions of these features. Now, some of the popular dialects of SQL includes Transact SQL or TSQL, which is a version of SQL used by Microsoft SQL Server and Azure SQL Database. PG-SQL is a dialect with extensions implemented by PostgreSQL, and Procedural Language over SQL is a dialect used by Oracle databases.
Now let's take a look at the elements that constitute to a typical SQL query using DML statements. First, we usually start with a select statement. You can use a select statement to retrieve data from tables and specify certain conditions. After the select statement, you would typically specify the columns of the data that you wish to retrieve data from. Now, the from statement is then used to decide which table to retrieve your data rows from. Then you can also optionally add a where clause or where statement, which is a conditional statement that specifies which data to include and which data to exclude, depending on the evaluation of the condition. If you're using some of the aggregation or summarization functions in the select statement, you can often use the group by statement to group the aggregation or summary that you're trying to do in the query. And the order by statement, which is again another optional statement that you can add, can be used to rank the results of the data that you're retrieving. Now, if we take a look at an example of a select statement, in basic English, this query or this statement is essentially saying find the employees who served customer 71 at least once and rank them by the employee number. Now in SQL, what I want to do is I want to retrieve data from the orders table in the sales database, and this is specified from the from statement. And the data I'm interested in are employee ID and the order year, which is specified in the select statement. And I'm only interested in the data where the customer ID is 71, which is specified in the where statement. I also want the results returned to be in groups of employee ID and order year. And so this is specified in the group by statement. And I only want results where there is a record return, and each of the results needs to be grouped if there are multiple records found. And so this is specified in the having statement. And then I want to rank the results first by employee ID and then by order year, which is specified after the order by statement. Now, if we take a look at an example of an insert statement, so in plain simple English, this is simply saying I want to add a new order to the orders details table. So in SQL, what we do is we insert into the order details table, which is inside the sales database, the following values. So for order ID, I want to insert 10255. Product ID, I want to insert 39. Unit price, I want to insert 18. Quantity is 2, and the discount is 0.05, which means 5%.
Now, you use DDL statements to create, modify, and remove tables and other objects in the database. So these objects could be tables, store procedures, views, and so on and so forth. Now, the most common DDL statements or data definition language statements are create, which allows you to create a new object in the database, such as a table or a view, or alter. So alter allows you to modify the structure of an object. For instance, you can alter a table by adding more columns to it. The next one is drop. So drop allows you to remove an object from a database. So if you want to drop a table, for example, if you no longer need it. And then rename is another one that you can use to rename an existing object. So if you wanted to rename a table, for example, that's where you would use the rename statement.
Now, if we look at an example of the create statement, this statement or this example creates a new database table called my table in the database. And so the items between the brackets or the parentheses specify the details of each of the columns in the table. So including name, data type, whether the column needs to have a value or not. So that's a not null. And whether the data in the column is used to uniquely identify a row, which is the primary key part. So every table should have a primary key. Although SQL doesn't actually enforce this rule, the primary key is then used to uniquely identify each data row item in the table. Now, columns that are marked as not null are referenced to as mandatory columns, which means they need to have a value inside those particular columns. If you omit the not null clause, you can create rows that don't contain values inside that column. So that means an empty column in a row is said to have a null value. Now, the data types available for columns in the table will actually vary depending on the database management system. However, most database management systems support numeric types like int, which stands for integer, and string types like varchar, which stands for variable length, and they generally contain text kind of data. So now let's have a look at how we can provision an Azure SQL database and also query data inside an Azure SQL database. So I'm going to head over to my Azure portal to provision and query an Azure SQL database. Now that I'm on my Azure portal, this is how I'm going to provision my Azure SQL database. So this is what the home page of my Azure portal looks like. Now I am using the preview version, so your one might actually look slightly different because preview means it's still in beta mode. So to create any resource, including an Azure SQL database, I can come into my left-hand menu bar, open this up and create a resource from here. Alternatively, what I like to do is I actually like to search for the resource I'm creating. So if I look up a SQL database, for example, I get to create a Azure SQL database from here. And so I simply go add, and I'm taken to the configuration page. And I need to go through those settings that I talked through earlier, starting with the basics. So I need to choose an Azure subscription to provision this Azure SQL database to. I'm using my internal subscription. And I also need to specify the resource group which this Azure SQL database will go into. So I've actually created one, but you can also optionally create a new resource group from here. So I'm actually going to create a new resource group and call it a demo. And now I'm going to place this Azure SQL database inside a new resource group called demo. Here I need to specify the database name. So I need to give my database name. So I'm going to call this my demo database, for example. And this checks out. Now I need to create my virtual SQL server for my Azure SQL databases. So I can come into here and I can create a new Azure SQL server. I need to give it a unique SQL server name. And so this name needs to be not used by anyone before. So for example, if I use demo, this is going to be probably invalid because someone's already created a SQL server with this name. So I need to give it something unique. So I'm going to call it demo and just pass it some numbers. Now, hopefully, yes, this one, no one has used this name for a SQL server, so I can create a SQL server with this particular name. And I need to also give it some credentials to be able to log into my SQL server. And so, again, we can't use names like admin. This will reject me. So I need to give a server admin login name that is relevant to my SQL server. So for example, if I say demo user, and I need to input some passwords. So make sure the password is strong enough and re-enter the password as well. Now, the location is the Azure region that we want to provision this Azure SQL database to. So currently, the default is East US, but I can come into here and I can select any one of the Azure regions around the world to provision my Azure SQL database to. I'm just going to leave the default East US one, and I'm just going to click OK. And that's gone and set up my SQL Server for me. Now here I can specify if I want to use a SQL Elastic pool. So it's simply a toggle between yes or no. Because this is a demo, I'm just going to leave it as the default no. And this is where I'm going to essentially pick out the size for my Azure SQL database. So the compute and storage is essentially where I'm going to configure how much storage and compute resources that I'll need to run my Azure SQL database. So if I come into config database, I get a couple of options and tiers that I can choose from. So general purpose, hyperscale, business critical. And if we scroll down a little bit, we can see the price of selecting this particular tier. Now I'm actually going to scale my database right down because this is, again, a demo database, so I don't need that much resources. I'm going to select the basic one, and then I'm just going to scale that all the way down. And I can see that the estimated cost for the smallest possible Azure SQL database is going to cost me about $6.85 a month. I'm just going to hit apply. And I'm going to go to the next tab, which is a networking tab. Now, with the networking connectivity, we can configure how we can connect to our Azure SQL database. Now, by default, remember that all access to our Azure SQL database is blocked. I can enable public access, or I can have a private endpoint access to my Azure SQL database. So I'm going to open this up for public access. And here I can specify some of the firewall rules. So do I want to allow Azure services and resources to access the server? Probably if I want to use an Azure virtual machine to access my Azure SQL server. And do I want to add my current IP address from this device to allow access to this particular Azure SQL server? So I'm going to as well. Now, if we go to additional settings, this is where you can specify the data source. And so we can create a blank, brand new database, or we can create an existing one so we can restore it from backup, or we can come in here and we can use some of the sample data that Microsoft Azure SQL database provides to populate our new database. So I'm going to select the sample one. And the sample database is going to populate data from the AdventuresWorks LT database. And down here, we can also set up Azure Defender for SQL. Now, this is that advanced threat protection, which provides the vulnerability assessment and threat protection for our SQL server. So I'm not going to enable it for now. And then we move into the tags tab. Now, in the tags tab, generally when you provision any Azure products or services, you would encounter this particular tab. Tags is where you can add metadata to your Azure resources. And the metadata we can then use to filter and find our resources once we've provisioned it. So for example, I might want to say that this particular database is a demo database. And after that, I can simply hit review and create. Now that's going to run a validation test to check that all the configuration details I provided is indeed correct. And once it checks out, I simply hit create. And now that's going to submit my deployment to Azure to go and set up that Azure SQL database for me. Now, because we are limited by time, I've actually set up an Azure SQL database already. So we can go and look at an example one that I've already set up. So if I go and look up SQL database again, I can find the one that I've set up before this training. So if I go into it, I can see on the overview page or the overview tab some of the details about this particular Azure SQL database. So for example, it's sitting in the DP900 resource group. It's subscribed to my internal subscription, And this is the SQL Server name, which is actually where the SQL database is running on. Now, if I scroll down a little bit, we see a query editor. So with the query editor, we can use this to query our Azure SQL database. So I'm going to come into my query editor. And I need to authenticate myself to be able to access this particular Azure SQL database. So if I wanted to essentially execute any queries against this particular database, I need to verify myself first. So I can choose between SQL Server authentication, or I can use Active Directory authentication. I'm going to pick SQL Server authentication, and I'm just going to put in the password for this Azure SQL database. Let me re-enter the password. And now I'm inside the query editor for this particular Azure SQL database, which means I can use this to start executing some of those SQL queries that I want against this database. So again, like the demo one that I set up, I've actually used some of the sample data to populate this particular database. So if I open up tables, I can see some of the sample tables and data that's already populated into this particular Azure SQL database. So I can minimize some of these panels on the left here to make more room on my screen. And let's just execute a very simple SQL statement like select. Let's look at the customers table. And this very simple SQL query is just going to return all the rows from the customer table so that I can look at all the data inside the customer table. So I simply hit run. And that query took 1 second to execute. Now, if I move down a little bit, or minimize the screen a little bit, I can see some of the results that were returned from the query. And so this is all the data inside the customer data table. Now, if we look at something a little bit more interesting, I can see that there is a sales order table in my database. So let's change this to sales order. So sales order, and hit execute. Now I can see all the sales order data in the sales order detail table. So it contains columns like sales order ID. If I scroll across, order quantity, product ID, which tells me that this is actually a foreign key which references the product ID in the products table. And so let's actually go and reference the products table from my order details table. And so if, for example, I wanted to find all the products that are inside the order details table and the products table, I can do something like an aggregation. Product P. So I need to give my tables that I'm querying from some aliases, because what I'm going to be doing is actually referencing the same column name. And so I need to have aliases to be able to tell SQL that I'm referencing the particular column. And so I'm just going to give this P, and I'm going to specify a where clause, which is that conditional statement where I can say I'm only interested in the results which will return me the product ID from the sales order table. That is the same as the product ID from the product table. Now, if I hit execute, I get a result of 542, which tells me that the total number of products that have been ordered is 542. Now, what's interesting is if I wanted to find out how many products existed, I can do a pretty similar query. So I can do select, count all the rows from the product table, and I can highlight this, which means I'm only going to be executing this particular query. So if I hit run, I find out that there are 295 products in the products table, which tells me that there have been at least one or more products that has been ordered more than once from the results that I got from my sales order detail table. Now, these are very simple queries, and you can do a lot more complicated and complex SQL queries, but this is just some of the power that you can do using Azure SQL Database. So you can use a couple of tools to query data held inside an Azure SQL database, like the Azure portal, which we saw. You can also use the SQL command utility or the SQL CMD utility from the command line on your device or using the Azure Cloud Shell. You can also use SQL Server Management Studio or Azure Data Studio or the SQL Server data tools to query data held inside your Azure SQL database. To use these tools, you need to first establish a connection to the database. So you'll need to provide some of those credentials to be able to log in to the server and connect to it. So the admin username and password, for example. Now, SQL Server Management Studio is a tool that you can download and run on your desktop. And typically, this has been used for connecting to and executing SQL queries to on-premises SQL Server databases. The SQL Server Data Tools is a tool that you can actually use inside Visual Studio to connect to your Azure SQL databases. The Azure Data Studio is a graphical utility for creating and running SQL queries from your desktop. It's much more lightweight than the SQL Management Studio, and it's a great tool for connecting to your Azure SQL databases because that's what it's kind of built for. Now, the SQL CMD or the SQL command line utility can be run from your command line, and it's also available from the Azure Cloud Shell. So you specify the parameters to identify the server that you want to connect to alongside with the credentials, and then simply after that, you can start executing your SQL queries through the SQL command line as you would in any of the other tools. Now, PostgreSQL provides many tools that you can use to connect to a PostgreSQL database and run queries on. These tools include PG Admin, which is a graphical user interface tool, or you can also use the PG SQL command line utility. There are also a large number of third-party utilities that you can use as well. And so let's have a look at how we can use the PG Admin tool to connect to an Azure PostgreSQL database. So now I'm back on my Azure portal. Now I'm not going to take you through how to configure and set up the Azure PostgreSQL server on Azure because it's a very similar process to the Azure SQL database. What I'm going to show you is how to use the PG Admin tool to connect and execute queries against the Azure PostgreSQL database. So I can see that this is the Azure PostgreSQL database I've already set up. And now I'm going to switch over to my PG Admin tool to connect to my Azure PostgreSQL database and execute some queries against it. So I've actually already entered in the configuration strings and login credentials to connect to my PostgreSQL. So I can simply open it up. And now under databases, I see that I've got 4 databases. Some of these ones are already set up by PostgreSQL. I've actually went ahead and created one called My Demo Database. So if I come into here and I go right click, I can create a script, which then allows me to go and execute some SQL queries against this database. So this is just the default ones. I'm going to erase it. And this database should be completely empty. So let's go and create a table. So I'm going to execute a create table statement, and I'm going to call this table customers.
Now, inside my customer table, I need to specify a couple of columns. And so let's say customer ID, which is going to be a primary key, and it's not going to be null. I'm also going to have a customer name, which is going to take a varchar, and let's give it 50 characters, and also not null. Now, I simply hit this play button to execute the statement. And we see down here that the query has successfully been executed. So now I'm just going to insert some values into my newly created customer table. So let's do insert into customers the following values. In customers, I also need to define the columns that I want to insert values into. So customer ID and the customer name. And let's just say I'm going to give the ID 1, and I'll just give it my name. And if I highlight this, I'm just going to insert one record into my customer table. And so that's been successfully executed. Now, if I do a select all statement from my customers table and highlight this statement and hit execute, I can see that newly created customer table with the new row of data that I've inserted into returned back to me as a result.
Just as with PostgreSQL, there are many tools available to connect to your MySQL database as well. That enables you to create and run scripts containing SQL commands. So you can use the MySQL command line utility, which is also available through the Azure Cloud Shell, or you can use the graphical tools from the desktop, such as MySQL Workbench. So let's take a look at how we can use the MySQL Workbench to connect to our Azure MySQL database and execute some SQL queries through there. So again, I've already pre-provisioned a Azure MySQL server and database that's running on MySQL. And now we're going to have a look at how we can use the MySQL Workbench to both access this MySQL database that's running on Azure and execute some queries against it. So I'm on my MySQL Workbench, and I've already pre-connected to my MySQL Azure database that's running on Azure. So I simply open up the connection, and I need to provide the password to be able to authenticate into my Azure MySQL database. You can see the admin username and the server connection string. So now I just need to put in my password. Hit OK. And now that's going to authenticate into my Azure MySQL database. So once I'm in, I've actually predefined some queries that I was executing earlier before this training. And so I'm just going to highlight them and run through the same process, creating a table, but this time we're going to create an inventory table in our Azure MySQL database. And so I have already set up a My Demo database here. And so I'm going to use my demo database, and I'm going to create an inventory table that has an ID as a column, a name, and quantity. I'm just going to hit this little lightning button, which will run it. And that's executed successfully. Now I'm going to insert a couple of rows, particularly these 3 rows of values, into my new inventory table. So I'm going to highlight it and hit execute. And I've inserted 3 rows of data into my newly created inventory table. And then I'm just going to select all the rows from my inventory table. And I can see here all the new values that I've inserted into my table. So banana, orange, apple. And finally, this drop table statement is going to effectively delete my inventory table to remove it from the database. That's effectively been executed. So if I go and highlight this select all from inventory table again, it should throw me an error. And there you see, because the inventory table no longer exists in my demo database anymore. This concludes the first part of this virtual training. I hope you've enjoyed it so far. We covered Module 1, where we had a look at core data concepts, and Module 2, where we had a look at relational data in Azure. So thank you for your attendance and participation so far. I hope you'll join me for part 2 of this Microsoft Virtual Training Day for Data Fundamentals next time.